Yeah, hi Bernard.
Hi, Subhash.
Yeah. So I saw your design on the your POC.
Mhm.
So shall we take in today's meeting? Start with this.
Sure. I made it deliberately very lightweight so
Yes.
that actually implementation and adoption could be very easy to discuss.
Okay.
Uh, but let's see sort of who's going to turn up here.
Okay. So you generally write in JavaScript, is it, Bernard?
Yeah, so that was a quick hack. I just did it in an afternoon just to sort of
Yeah. Okay.
demonstrate the proof of concept. So I normally would have taken another program if I wanted to go for production, but it's just to
Yeah.
demonstrate the concept.
Right.
That's
Yeah.
the idea.
Okay. Yeah. Hello everyone. We are just waiting for folks to join. So we'll give one more minute, and then we'll start. Okay, so we have passed 3 minutes. So let's start today's meeting. Of course, today we see a limited audience. So, but yeah, of course, let's start. So today is 22nd February, and this is the work group 5 meeting where we discuss around the service assurance. So as part of the agenda, let me share my screen. Yeah. So could someone please confirm if my screen is visible? So I'll go ahead.
Yes, it is.
Okay, thank you. So so yeah, for today, we have planned 3 items to discuss in today's meeting. So first one is our user story on the impact analysis. So in this particular user story, Bernard will take us through his demo, and also will based on that demo, we can discuss this user story, like what we could achieve it. And the second one comes about our the previous one where we have captured the review comments on the service assurance framework, which is targeting to ODU. So in the last few weeks, we are still discussing on it, and we are trying to converge on it. So I'll just show like what comments we have captured, and I'll invite everyone's comment there also. And the last and the third topic where we will try to get some updates from the observability side, like how they are progressing and what exactly they are developing, so that service assurance could consume it. So with this, I'll jump on agenda points. So the first one, user story on the impact analysis. So Bernard, would you like to take from here? Would you like to share your
Yes,
screen?
if that's, yes, I will.
Okay, I'll stop
So
sharing
let
and
me just see if I can share that. Okay, hopefully it should work now. And just a short recap of what is this user story about. The idea is that we are, as a telco operator, trying to capture sort of a deployment description in a model. This deployment description contains many, many resources which will need to be configured. Could be that during this configuration process, new resources are inserted into the packages. And in the consequence, sort of when we are rolling out those resources, we might lose track of how those different resources belong together, how our high level intent, which I would now relate to a package or a set of packages, would relate to sort of the things which we are observing later on via the observability mechanisms, which we are discussing in another work stream. So here the idea is to derive a mechanism which allows us to correlate information, map those elements together in such a way that a telco operator can easily understand if something goes wrong, what kind of services are impacted, or on the other way around, if we're talking about sort of issues on a service level, on a customer level, sort of that we can determine what kind of elements we should look at in order to determine possible root causes for that. Yeah. And the idea is that as a starting, if there are questions, please jump in.
Yeah, I have a quick question. Actually, why is this related to service assurance?
Because if you don't know what you would want to observe, yeah, basically you're just observing everything, and later on you would have to make sense out of how does that what you've been observing relate to the intentions you've been sort of addressing. That means just imagine that we at some point in time would get sort of from the vendors sort of packages where they say you only have to sort of now do a slight modification of the packages and then roll it out. And on the other side, we have open telemetry solutions, which are now going on the nitty-gritty level of looking at pod services, service mesh instances, etc. And they're capturing a lot of information. And then the question is, what does that actually mean? How does it relate to sort of the packages which we are observing? If there's a cluster going down, what kind of elements are sort of impacted, etc. This type of information would need to be sort of anyhow configured into our service assurance systems. So the idea is to make this a machine read.
So my view is a bit different there, is that the service assurance need to be able to access it, but it's not the job of the service assurance to deal with it.
You need to have the information available. I'm not talking about
because
the cycle.
The reason, yeah. Let me clarify why I'm saying that, right? Because this problem space we are addressing in NF2 infra, exactly. So in NF2 infra, this is exactly what you need in order to be able to do the NF2 infra job, right? So as such, so what I'm trying to say is that if that information is available to service assurance, then they can consume it, but it's not the job of service assurance to define, to get this data or get to this data.
No, let's say it's not the job of service assurance to generate that data, but the data should be available. Is that
correct? Yeah.
Is that okay?
That's why I'm saying so service assurance should be able to access that data, but it's not the job of service assurance to generate that data, right?
Yeah, so, and to be honest, I'm not a big fan of separating lifecycle management and service assurance into two different parts. I believe they belong together. And that's why I'm saying in the context of the Nephew configuration processes, I would like to have one place where this information is generated. If I put that into the badge of service assurance or I put that in lifecycle management, I don't care. But at some point at time, this information needs to be generated. And that's what I'm trying to aim for here in this user story. Yeah. So
yeah. So so the information is actually there is a component in NF2 infra that exactly does this, by the way.
But not for the sort of package internal dependencies, I assume, and not for the package sort of inter-package dependencies.
For both.
Because
so if a certain package need to get a new resource, right, there is a new dependency, so that it does it for both. Because otherwise you cannot build a full tree, right?
Yeah, but even if you have a tree, sometimes you do not see the relationships between the elements. I'll try to show that later on, what is missing from my point of view. Yeah, so but maybe I like to be corrected, and I believe we could also converge the approaches. Yeah, so not saying that it has to be exactly like this, but the scope of what the result should look like and how the result should be presented is something where I do have an opinion of how we should make that available. And NF2 infra, as you are already rightfully sort of naming that, is very much focusing on how does a network function try to define the dependencies to the infrastructure. That's fine. Yeah, and I think it's a good approach. We started this discussion, you might remember, a couple of months ago. But now I'm talking about the package internal dependencies as well as sort of inter-package dependencies, which might not even be related to sort of the infrastructure related requirements.
Correct. Yeah. So the whole concept in the dependency manager is no longer so the whole thing is not so it's still called NF2 infra, but the whole dependency tree is, you can use it for anything these days.
Very good. If we can combine that, I'm fine with that. I'm not saying that it has to be like that, but I need this functionality also on a level which I will try to describe a little bit later on. Okay. Yeah. So just keep in mind, and if we can map that, happy to go for that. Yeah. And I've also been looking into the KPT status solution, and I said,
by the way, so NF2 infra doesn't use KPT, by the way. So it's using a different.
I try to explain also why I'm sort of very good. Yeah. And I'm heading in the same direction. Yeah. So the idea is sort of the DevOps teams in our organization, they are managing these packages. The packages have an internal structure. There are also interdependencies between the packages. There are interdependencies between the packages for network functions and for workloads. So all those things we need to account for. And that's why when I was looking at the solution, I wanted to see something which would allow to do the processing of this dependency information independent of the tool which is generating that information. That information could be coming from the vendors. The information could be generated on the fly. It could be generated from different tools, but this information should sort of follow a standardized format where we say, if that information is available, then we could use that easily from a service assurance part. And the service assurance part shouldn't have to try to sort of collect sort of different types of entities from different elements with different semantics, different protocols. This would make service assurance too complicated. So here, this dependency information should ideally be somehow sort of easy to sort of consume. Then it should allow for a sort of describing the internal dependencies, which sometimes are implicitly there, but not explicitly mentioned. Yeah, so sometimes you just put two parameters in different attribute fields, and implicitly you know that this is an IP address and the other one is a service endpoint, but sort of there's no explicit mentioning that based on this common view of the attributes, that actually there's a dependencies between those resources. So this should be really externalized and made available to the tooling. And there's also an additional notion that if, for instance, the vendors would facilitate sort of the resources by sort of mentioning, by the way, I have dependencies to other elements, then there should be the possibility to also, based on this information, externalize that into this common format. Yeah, so there's sort of certain approaches where I say it would be great if we could allow for that. And the idea is that there should be if that is not available as information provided by the vendor in advance, there should be sort of a function which in the context of the configuration management would take care of identifying the dependencies in the configuration process. That means before the models hit the API, and based on this would generate a dependency graph information, which would then serve as an input for any kind of external service assurance tools, which we might want to make use of. Yeah, and that means sort of as a simplistic view, as an implementation proposal, there was one sort of approach to say, okay, if we've got a package sort of, and in this package processing approach, sort of we are making use of different manifests for different types of custom resources, there should be some kind of possibility to have a KPT function, which basically passes all this. Basically, the input is a standard in, you get a resource list, then sort of this function then sort of calculates all the dependencies, either looks into the annotations of the internal resources or calculates based on sort of the knowledge that there's a relationship between, for instance, services and deployments or stateful sets. It sort of creates an updated resource list with one additional element capturing this dependency information. And this additional element with this dependency information should have a certain structure. And again, the structure, if we've got another resource coming from NF to infra, which fulfills the same requirements, I'm fine. But here in this context, sort of the approach would be that if you sort of are familiar with this KRM KPT function notion, basically what you're seeing is that all those resources are then compiled into one resource list. Each resource is basically a YAML entity and YAML item where two additional annotations, internal config Kubernetes IO path and internal config Kubernetes IO index, are being describing the location and the index of the resource. And then there's basically sort of a group version kind identifier for the entity type and the name of that resource. We could augment that also with cluster and work namespace and possibly indexes. But basically, there's this reference of saying this resource has a set of other dependencies, be it also identified by group version kind and name, or even more attributes as needed. And this simple list of resources allows us then to build a hierarchy, a dependency tree based on sort of the input which we have here. And as an example, what I did is I created a small sort of mock-up for that, sort of just making use of the free 5GC control plane function, which would sort of take that in as an input and generate sort of this dependency YAML file. And based on that, I also wrote a small converter, which was then able to sort of then show this as a plant UML diagram, for instance, to just depict what kind of dependencies between the packages and internal structures of the packages are sort of being made available in this context. And I believe there are much more dependencies, by the way, where I would ideally want to make use of the annotations and say, look here, there's sort of, if we've got sort of different network functions, they will typically also wait for the NRF to come up, etc. And so these types of dependencies are not shown here and could sort of be augmented by annotations if needed. But this is the type of information which we need so that we understand if, for instance, something goes wrong in the control plane, we know where to look at and what kind of entities we would, from a target architecture picture, would have to reflect. After the package has been deployed to the clusters, of course, you could take the same information, which is now currently in the spec of this dependency graph, and then actually map it to the current status of the pods, etc., which are then actually implementing this target picture. And we would then have a sort of a live view on the elements which have been deployed and which would then sort of allow us to, again, to sort of determine what kind of root cause analysis and impact analysis aspects we need to consider when making use of external tools here. So that is the proposal. I'm very much wanting to see some kind of structured way of capturing the dependencies, making that sort of part of the process, so that before we are actually handing over a package to the APIs, we have this dependency information available for processing via any kind of service assurance tooling which we might have in mind, depending on the setup which a telco operator might want to make use of. And now the floor is open for discussion about sort of what we might want to consider here.
Shall I go ahead?
Please.
Yeah. So actually, I have two questions. So do you think we are trying to build some sort of topology out of it? So that the service assurance system, which sits on the top or maybe within the nephew, they can consume this topology?
Exactly. This is topology. This, what is generated here, is topology information. Yes.
Okay.
And we could actually be even more expressive. We could also try to categorize the types of dependencies which we're looking at, in the sense of, is it a sort of a clustering dependency where we say sort of we only are requiring one of the sub-elements to be available, or is it sort of a dependency which directly has an impact? If it's not there, then the other element will also fail, etc. So all those things which we typically would facilitate in the context of event correlation, this type of categorization we could put in addition to those elements. That means sort of, if you have one resource here, I'll just highlight that, one resource identified by group version kind and name, and we have got sort of a dependency to another resource here. We could also categorize the dependencies and say, look here, this dependency is of type ABC, and based on that, the correlation which routes which might sort of be taken into account might account for sort of cluster relationships or direct relationships, etc.
So that relationship, actually, we're calling it is a dependency. Is that relationship between two entities, or we are seeing in the context of deployment only, or there is some other things also we are seeing for the relationship?
Service accounts which might not be there, or sort of any kind of relationship which we believe is of relevance should be highlighted here. Yeah.
Okay. And yeah, second question, what I was thinking, currently I think our we've only will limited to NF topology. I think we cannot go beyond that in the management cluster, because the package finally gets added to NF topology, and only the workload cluster is responsible for converting into further deployment or pods, right? So visualization will be limited to NF topology. I feel.
No.
Sorry, NF deployment.
No.
I think. Okay.
No.
Okay.
So this is a general concept. So it's sort of we can propagate that information, and we can try to also sort of, if we're sort of doing a fan out to different workloads, workload clusters, of course, sort of, at the end, if I were to try to correlate those informations, I would probably stitch that together, but with the knowledge that sort of before I hand it over to the next step, that all the dependency information which was accumulated so far is complete. Yeah, that means I would not want to have a sort of a hole in the declaration and say, here now we've got a white spot, we don't know what's going on there. But basically, if I were to want to manage that, I would need to have this consistent information from all the clusters. And this structure here is so generic that it's applicable for everything. But I assume when I get the statements from Wim right, it's this type of mechanism is also probably similar in the context of NF2 infra.
Okay. So if I understand correctly, so we need some mechanism also to propagate the information from workload cluster to management cluster.
So first of all, I'm just saying it has to be there. I'm not talking about how do I get it.
Yeah.
That means the only statement is, in the context of the processing, before I hit the API, I want to have this dependency information available. Yeah, so that I know from the dependency information is an input to sort of describing how the target state is related to one another. And after I've sort of propagated it to the API, then of course it will be processed further on, and there might be sort of in the status a different sort of set of pods and availabilities to be considered here. But at least I've captured the target architecture and the dependencies of the target architecture in a machine readable format.
Thank you. Thank you.
So let me share. So maybe let me share where we are with with the NF2 infra. You'll see that we have this very similar story. You see my screen?
No, not yet. I'll just stop my sharing, and then maybe you can do that.
You see my screen?
Still black currently. Oh, now I can see it.
Yeah, so we have a similar, so for every package, right? So you get the dependency on every resource, you see? So this is the resource, which basically has a GVK group version kind, right? So this is at the moment a static. So we have two basically dependencies in NF2 infra. One is static dependency and one is runtime dependencies, but the structure is the same, right?
Can I see the model? Is there any kind of resource
it's
model?
Very similar to what you have. Now,
okay.
So the reason I was highlighting this is, so it's very hard. So what you see, you show basically two levels of dependency in real. So when I looked at everything we do in Nefio today, you already have a level of 4. Okay. So
yeah, the approach. Wait, just one moment. So the approach which I've been showing here is a cascaded approach. That means by sort of looking at each of those resources and their sort of next dependencies, I can create a tree of any depth. Right. To determine
that's
topology.
Why that's what I wanted to clarify, because that's exactly what we are doing, right? So basically, you see per package, you see all the internal dependencies here, right?
Yeah.
And then you can build. So for example, this package is depending. There is only one resource here, is depending on another package. So with this you can build exactly what you're looking for, right? Because this is basically depending on another package. So you have to do a lookup of that package, and then you can build the hierarchy. That's what we are basically doing, because we need that in order to instantiate the packages and know that a certain resource is available already before you can deploy it. So there is, for example, you cannot. But what I'm trying to say is that we should discuss this in NF2 infra, in my view, because this is what we are looking at and creating that whole tree, because then we have one mechanism for everything.
Very good. I'm very happy to go for that approach. Yeah, but let me try to be very, very specific about my additional requirements, because for me, it doesn't suffice to say sort of, since a resource is in a package, I just do a link to the package between the package and the resources, and then say there's a dependencies to that. I would also need the inner package dependencies. That means how a service is. Yeah. Yeah, but can I see, for instance, the service to deployment dependency? Where would I see that?
I mean, if it's not here, but there is a deployment here. In this one, there is definitely a deployment. Where is it?
But there should be a service to deployment dependency, for instance. Yeah, because you're saying we're exposing this service, and there's a selector which then sort of is fitting a certain deployment package.
Sure. So that's fairly straightforward to do. But yeah, so I think
I agree. Yeah, but those things are the things which I'm saying. I just wanted to mention that. Yeah, that means this type of mechanism of not only looking into the package structure, but also into the elements and how they relate to one another would be one thing I would like to see. In addition, I would like to see the mechanism where a resource could potentially announce dependencies to other resources. Yeah, where
that's what we say, look. So the structure that we are, so what I'm advocating is that every package you can specify requirements, right? So and they would be explicit.
Exactly.
So for source we have what I call a claim or a requirement, and with
wait. Yeah, wait. There's one thing. You are now relating those requirements to the package level. I want to
No,
relate it
no,
to the resource.
Oh, the requirement is based on an API, not a package, and the API can be within, it's probably within a package, but yeah. So there is, so the requirement is on an API. It's not on a package.
Yeah, the
Because
reason why I'm asking is,
Kubernetes, if you look to how Kubernetes works at the end of the day, it's a set of APIs, right? At the end of the day,
yeah,
and that's why I split it here between core and so if you look to the API system of Kubernetes, you have core APIs which are coming baseline with Kubernetes, and you have extensions. And there's two ways to do extensions. One is CRDs, one is API server, right? So what you do for every API, because that's basically your consumption model, you can specify a requirement on that API that, or you map it direct. So you basically have two methods. And so with that, you can build any relationship to any resource that is available in the cluster, right? And so, for example, one of the things that you, for example, have is that, let's say I create, so this package now is only, let's say, dependent on the core resources. So this is, that's why there is core dependencies and package dependencies, because if you extend the API, you need a CRD or an API service, and that will be owned by a certain package, you see? So in other words, when you do that, so for example, if this package would say, I need to have access to that CRD resource, you have immediately an implicit dependency to that package that owns that API, if you see what I'm saying. And so with that, you can...
The only thing which I'm just trying to come up with, and help me please, Wim, if I'm sort of heading in the wrong direction. My thought was there are different ways of how I can generate this dependency information. And ideally, I would like to have it as a custom resource being available for any kind of further processing. Yeah. So the idea is that sort of in order to generate that, I can either have an intelligent function which then sort of goes to the packages, identifies what's going on, and then says, look here, this is the dependency information, and sort of puts it into some kind of custom resource, which can then be scraped by any kind of external system. And in addition, there might be the possibility that sort of in the previous steps, there was a vendor who was so kind to say, look here, my component actually has a certain set of dependencies. And I can now make some, for instance, annotations or whatever to indicate that these dependencies need to be considered. And by externalizing this information, I can facilitate this sort of dependency graph collection information process to sort of make sure that also these considerations are being accounted for.
Now, so for me, the big question is, why do you want to have an additional resource and not just be dependent on the API? Because at the end of the day, the API is what we consume, right? So if a vendor... So for example, let's say I need Multus, right? So let's say I need Multus. For example, the package says that you are implicitly dependent on the API. You see what I'm saying? So but
the API has a certain data structure. So of course, the API allows me the access, but the important part is the data. Yeah, and that's why I was just sort of wondering, sort of.
So my mental model right now is the following: for any resource that we consume inside of the system, you have an API. Right. That's what we basically did for release 1. So for example, we need an IP address, we have an API. Right? We need a VLAN, we have an API. We need a kernel module, we have an API, right? So in other words, if you have that, then there is no, in my view, no need for anything new. Then the dependencies will be a result of the API. Because if you as a vendor want to have a specific implementation, for example, that means that now I will not be able to deploy this unless I have that resource added to my cluster. You see, so you eliminate a bunch of things, and you also move towards a KRM based.
How would you how would you express in a declarative model this requirement. So imagine you sort of are, as a vendor, packaging your solution and wanting to indicate that sort of certain elements are related to one another in the package, as well as you might have requirements towards the infrastructure or to other packages. How would you express
first define, let's be specific. So let's say you're dependent on something. What is that something? Is that expressed through an API or not?
I would express it in the sense of I'm expecting sort of, for instance, the NRF function to be available. Yeah. So just imagine that I would be
API,
creating.
Right? So that's an API, right? Because that's a deployment or a stateful set that you are expecting, right?
Yeah, but again, also the API needs to be triggered with data. For instance, I would say
Yeah. So you can say I need an NRF with this name, for example, right? So your dependency is deployment with this name. So that's why I'm saying is I don't believe we need anything else than having an API system, and you basically refer all your dependencies towards that API. If you do that, the system is just building the dependency on the APIs, and that makes it very generic. You just have to make sure that for every resource.
No. But again, sort of we're going for sort of, let's bring together the declarative model and the API. Yeah, that means sort of as sort of a telco operator, we are trying to say we are getting artifacts and manifests, etc. We are going to package them, and this information block, this information block will be handed over to an API or set of APIs. But in this information model, which I'm capturing, I need to also describe the dependencies. I will not do that sort of somehow with sort of functional logic in it. There's a declarative model which says what the dependencies should look like. And that's what I'm wanting to understand. That I didn't quite get how you capture within this manifest or set of manifests the dependencies which you would need to support here.
By basically referring to the APIs that you need. So for example, if I want to, so let's say I want to have a VLAN, right? So you basically say, I create a VLAN claim with a certain name or a certain set of attributes, and there is an API that refers to that requirement. And that's what we have been doing so far, right? So, and I think it's a very powerful model because, by the way, just to be clear, those APIs don't have to be attached to the cluster, so they can be living just within a package, which is just used to be able to get access to it, right?
Does that only work after you've hit the API, or can that also happen in the
So
configuration
in other words,
phase?
we just express for all our requirements an API. And what I'm trying to get to is not all of these have to be actuated to the cluster, but they can be, for example, if you look, what we did so far is that we have an IP claim or VLAN claim was a resource that we had that was actually in the cluster, but you could also make this just available through a package, which is just used then to render something out, right? But so what I'm trying to get to is that if we express all our requirements through a KRM object, we can use the KRM power to do all of what you say.
Yeah. So, but basically, what
as a result, you don't need additional things to do something else, because we build on build, and I try to come up with a scheme that is just one thing, and you use it.
So to be very explicit, now if I'm the service assurance tool manager within my organization, and a service assurance guy, and I want to get this topology information of the cluster or of the solution, the target state, will I only have to ask one API to get that?
Yes. So you go to one element and you say, okay, give me all the dependencies of this resource, and then you basically get it in one shot. Yeah. but it's not modeled immediately in a CRD, right? So it will be through some lookups that you have to do, you get the information, because what I experienced that if you build this one big tree and you want to map it, first of all, it's changing potentially, right, regularly. Plus, how many levels do you have to model? So I was of the opinion that you model one dependency within your resource, right? And then the tree itself is a result of looking up each of those items. So that's basically what, if you query the API, what you will do is you will ask, okay, give me the dependency tree from this resource, and then you get a full tree from there.
Okay, you iterate. But could you just show me sort of this one level dependency description in the resource, how you model that?
So here right now, it's basically, so this is the package, right? And here we model it as GVK. So we know the API, right? So which is core, right? So this is Kubernetes v1 secret, and then the name is missing here, right?
Sorry, help me please. But this is not a standard manifest, which I'm looking for this kind sort of metadata.
So this is the
type of.
So this is at the moment. So so this is a package which has all of these resources internally, right? Okay.
Yes.
So this is the first level. So this is so the name here is just, so I call it internally right now package dependency, right? So package dependency with a name, and it has a revision and stuff like that. So it is GVK based. So each of these are packages which have group version kind, namespace name, which is basically this. Okay. And then within that, you have for every resource, you basically, and you can have, so you see here, this is, okay, I am depending on a secret, right?
Can I see this relationship in exactly this resource? I would like to see.
Yes,
how
correct. So
modeled.
this is what I'm just dumping something that I just mocked up quickly, right? So, but this is how it's represented, right? So this is the package. These are all the resources. And here is another example. Here there's only one resource, but this is the dependency on another package. You see?
Yeah. So my thoughts. I want to see sort of a Kubernetes resource description here. This is not a Kubernetes resource description.
No, this is a dump. I'll give you the CRD. I'll give you
that's what I wanted to see, so that I better understand how that is modeled. That was my request here. Yeah. So that I can sort of better understand the structure and what the capabilities of that description model is. Yeah.
And with that, so what I'm doing right now, for example, you deploy, let's say, SMF, right? And it needs Multus, and it needs a VLAN, and it needs an IP, and it needs this and that and that. First of all, it checks, is the resource available? If not, it will install it. Then if it's, so it's basically building that whole thing up. And then with that, so there is, we have at the moment 2 trees. One is what I call the static tree, which is just to get you access to the APIs, right? So because unless the API is available into the system, you cannot consume it, right? So that's resolved through what I call static dependencies, and then you have the runtime dependencies, but the structure is the same. So the runtime dependency is what you're talking about, which is what you have with where you have specific resources with specific data. In the static elements are just typically used for the API consumption.
Yeah.
But okay.
So actually, what I believe is that what you're actually allowing for is a much more powerful approach than what I was aiming for. I'm trying to explain why, because basically by providing this API, you're not only talking about there is a relationship, but potentially also retrieving additional information such as service endpoint, etc., to actually provision the configuration needed for that. Yeah, so that's more than what I'm aiming for. But I believe that we might have to see how we can simplify as much as possible, because on the first look, I get the impression that it's a little bit complicated, sort of how it is implemented. But I would like to investigate that a little bit more. So my question is, can I get a sort of a set of links so that I can resync with your understanding here and then
Yeah,
possibly sort of then enhance sort of the approach if possible.
I'll share the CRD. Yeah, correct. Yeah.
Okay. Then thank you for that. Again, sort of might be that I will come up with sort of things which I believe might be missing, but if we've got a common approach, that's even the best solution to go for here.
There's more
Yeah,
questions.
and I hope. Yeah.
Radha has its hand.
Yeah, Varda, please go ahead.
Right. Bernard, in the document which you have shown, I'm interested, with respect to what is the input, in the form of intent or something from the telco operator to your use case.
From the telco operator perspective. So actually the telco operators would like to be as lazy as possible. Yeah. But we notice that sort of in the end, when we're doing service assurance or debugging, unfortunately, we need to go into the nitty-gritty in order to understand why certain things have failed. And that's why we need this dependency graph, because what we are noticing is that we are unfortunately becoming more and more integrators. Yeah, that means so we've got different cloud setups, we've got different network functions, and we need to bring them together and monitor them, and at the end assure sort of the end-to-end service quality to our customers. And so therefore, in this process, the idea was to simplify this integration task as much as possible, to at least get the dependency tree of the different elements, so that if something goes wrong, we can quickly identify where to look at and whom to inform about the issues which might have caused major sort of problems to our customers. So in this sense, actually, we would only want to basically have a process which gives us this dependency information without us having to add additional information. But we would rather say, look here, dear vendor, when you're providing your package information, please help generating this dependency information, for instance, by this annotation, which we've just been discussing with Wim. That means if we've got in the package level or on the resource level, this indication of how the different elements are related to one another, this would be great information for then providing additional input or topology information for the service assurance activities.
Okay, yeah, something like a troubleshooting. Okay, so in that, right, you expect only the dependency means just the package, or even the configuration. See, ideally, if you see, right, in a telco world, there must be a relation between, for example, I'll tell you about the coverage. Okay, coverage has a relationship with antenna tilt. Both sits in different packages. And are we talking just about, is it something which can be done at the package level, or sort of?
So I must admit, I didn't want to sort of address all dependencies which there are, because we haven't been talking about transport, we haven't been talking about core, etc. So, sort of in the context of how they would work together with RAN. So I was just going to the basics, and the basics currently are that we're even having a hard time bringing together logs from the infrastructure with the logs from the network functions, because these dependency graphs are missing and the correlation rules are not there. So therefore, I just wanted to start with this area, and if you can extend that approach to larger domains, that would be great. But let's make sure that we're having sort of done this homework, at least sort of for the NF to infra, package to package, and intra-package dependencies in a well-defined way, because currently we don't have that information sort of in a standardized way available.
Perfect, Bernard. Yeah, got the scope.
Okay. So yeah, so thank you, Bernard, for your demo, and also showing the entire idea. With this, we'll directly jump on our second item. So actually, we had already discussed this part. So just I'll take 2 minutes. It's like in this particular document, I tried to capture all the review comments in this particular section, review comments. So there I try to capture my perspective, and also the Wim has also provided some valuable comments there. So I invite everyone's view there so that we can discuss further. Okay, so this with this actually Wim, actually I have one query after you explained the NF to infra to us. Yeah, with your explanation, I feel that there is why you are telling us to focus on the actor. I feel NF to infra could help us to achieve this part of placing the actor or deploying the actor, right? I think that there we are getting
That's
uh,
what
co-
I agree. That's why I was saying focus on the core of service assurance.
yeah. I'm getting your idea that with the NF to infra, we could express our dependency in the package itself. That
What you have to do is ask what it is, right? So, for example, you need to know where the, let's say, network function is deployed, right?
right.
For example, you can just ask.
I see. I see. So
And
is
by
it?
the way, actually, it's not even like that. It's actually even different. You basically say, I need an actor assigned to this thing, and NF to infra will deploy it for you, basically.
I see. So, Bim, is it possible that you just help us to fix this particular flow by using the NF to infra and also share the details on the NF to infra so that we can also understand it and discuss on it?
Yeah.
I think that would be great if you can fix this with the
That's
NF to
because
infra.
the only thing that you actually have to do is say, I need an actor, I want an actor pod, right? Associated with this, and the rest will happen for you.
Okay. Okay. So yeah, with this actually, I have one more comment. Is it really possible? The service assurance provide the requirement to NF to infra, and also we start using it for this requirement. I start seeing these things.
See what NF to infra does. I mean, the original point was the following, right? So we wanted to have a network function, right? Network function deployment needs a bunch of stuff before it can apply. Let's say, make it easy. I need an IP address and a VLAN, for example, right? So now, if you look, the approach is not really specific to. If you look at the problem statement, it's not okay. Although we call it NF to infra, it's applicable to any piece of software that you want to use or install or consume, right? So as such, if you have a mechanism to express your requirement, if you will, right, which we do through an API, you basically can do almost anything, or it solves the dependencies, right? So it just assumes that you have an API. So in this case, your actor pod is most likely a deployment or a stateful set or a pod or something like that. So which is an expressing through an API. That's why I've been pushing to do that, because if you do so, we use the full power of KRM, in my view. And that's, I think, where you see a lot of benefits coming from, because now we are using in my view, the intent of Nephew was to leverage KRM as a whole. And if we do that, we can use very powerful mechanism and reusable components that are not only applicable to service assurance, but applicable to anything. And that, for me, will be a win for all of us at the end of the day.
Right. I understood, Wim. So is it possible, like we can collaborate and fix this particular part? So you can fix this part with the NF to infra, and I'll try to focus on this particular piece for the service assurance so that we can leverage everything. Sure.
No, sure.
Okay. And also please share the documentations also. Okay.
Yeah.
Thank you.
There is a doc.
Thank you, Wim. Yeah, thank you. I think we are getting a way to move forward with this particular user story. Yeah, thank you. And we have another 7 minutes remaining. I'll go back to agenda item.
Yeah, one more thing, Subhash. Even for this NF to infra win, we want to know, what is the telco operator use case? Okay. Similar to how Bernard was telling, right? Yes, I want to see the dependency of packages and resources. So similarly, what is the telco operator use case? What he will do.
I can help here. I can help here because I was also triggering this NF to infra activity a little bit.
Right.
We have the issue that sort of we want to make use of our hardware efficiently. And what we're currently seeing that is that we're for each network function typically building an own cluster, complicated procurement processes, dedicated structures, which are sort of very difficult to change. Now, the approach is to say, if we could somehow describe the requirements which we have to the infrastructure in a declarative model, and then sort of have an automation mechanism automatically account for those dependencies and support and pre-provision all the things like kernel modules, sort of drivers for hardware acceleration, etc., before doing the actual onboarding, then we could more easily sort of shift our workloads, reuse our workloads on the existing clusters and be much more dynamic in provisioning our services. So this decoupling of or disaggregation of hardware and software led to the issue that not all hardware and not all software easily work together before we haven't properly configured them to account for the special requirements of the network functions. And that was the main reason why we wanted to have a declarative approach, which would allow us to automate the onboarding and provisioning processes for the network functions.
Great, great, yeah. Do you think the same system can be utilized for service assurance?
Yeah, so I think, so I mean, if I abstracted one more level from what Bernard is saying, right? But I think when we started with NF2 infra, we had the following requirement, right? If so, the operator would say, I want to deploy this network function, right? And just that's the only thing they express, okay? Now, and for example, why it's related, why it's the same for service assurance in my view, because what you are expressing, I need an actor pod. So think of it the same way, right? So now what, of course, the NF2 infra is way, or the thing with the network function is way more complicated, because now you, maybe more complicated, but you have, let's say, you first of all take NF, take for example, let's say we standardize on NF deployment, which is a NFU construct, right? So first of all, you need to figure out, is the CRD available in the cluster, right? Then that network function has potentially a requirement on Multus. Is Multus installed in the cluster? I need a VLAN. I need this kernel module to be installed, right? So if you look at this, then if we have a mechanism by which we can do this in an automated way, right? So that was where we came from. Then that was the requirement, if you will, right? So from just saying I want to deploy an SMF, right? And whether the vendor is specified or not doesn't really matter. And so that's basically was the requirement where we started from. And now when we were designing it, it came clear that that thing is not necessarily tied to NF2 infra, if you will, because if you, for example, need a piece of software, right? Or let's say you need, let's make it specific to service assurance. Let's say you have a service assurance CRD, right? That you have defined, in which you express which information you need and your actor logic and stuff like that, right? Let's say you want an actor pod that consumes it. So the only thing that you actually have to do is say, I want this service, I want this CRD with some specific parameters to be installed and associated with this network function, right? And that alone will trigger the rest of the job. Because you are now able to express your API through an API that you want service assurance. That API has a CRD. The NF2 infra will check, is the CRD available in the right place? If not, it will install it. Is the pod deployed? If not, it will install it, right? So you see that the mechanism or the pattern behind. So what I always try to do is build a pattern not specific to one thing, but make it generic, right? So if we can do so, we can reuse it for multiple things. That's why, for example, package variant is a nice construct because you can use it almost for anything, right? It's not tied to network functions. It's tied to clusters. We can do all kinds of stuff with that. So if we can build or find these patterns and make a reusable component mechanism out of it, we benefit overall, right? Because then that means that we want to reuse that system in various scenarios. And that's what we, came up with basically.
Yeah. Thank you,
Okay.
Vim.
Yeah.
Thank you, Vardhan. So actually, we have one more item. So sorry to cut the discussion. So, Stephen, if you are available, could you give us some details on the observability, updates on the observability?
So I don't believe that the time will be sufficient. We're nearly at the end of the hour, so we should try to reserve that for the next time.
Okay, sure. So Stephen, would it be possible if you share your updates over the Slack itself? I'll add these things here in the meeting.
Yeah, I mean, we just had our first Cooper meeting earlier this week.
Okay. Yeah, sure.
And then one of the items on the user story, or the stories under the epic is actually not on API. That was correctly. So,
Yeah, sorry.
Is it only for me? Like
yeah. Some voice is faded.
Yeah.
So yeah. So from next time, I'll try to make it first. Then I'll go to the next one. Sorry for that. Yeah. Thank you, everyone, for giving their time and joining this meeting for the discussion. Thank you. Let's meet next week. Thank you.
Yeah. Bye. Bye all.
Bye-bye.
Bye-bye.